Okay, this will be quick. State the number of complex zeros and the possible number of imaginary zeros for each function. So the possible number of the exact number of complex zeros, all you do is you look right there. You look at the highest degree exponent, and that's the number. So there will be 3 complex. Now remember, complex numbers can be either real or imaginary. So when we say complex numbers, that complex roots or zeros, that includes every type. Now, when we're talking about imaginary zeros, remember when we get into the imaginary numbers, it's because there's a negative sign underneath here. And when there's a negative, say that you have a -2, well, you'd rewrite that as -1 times 2, and the square root of -1 is I. That's where you get your imaginary numbers. Well, remember, when you pull out a root, there's a positive and negative. Imaginary zeros always come in pairs. So when we're looking at this exponent of 3, so 6x cubed, well, remember they come in pairs, so you have to look at the exponent, the even exponent closest to 3 without going over. So you have to treat that as if it really says 6x squared, and we know that there's either going to be 2 imaginary zeros or there will be 0 imaginary zeros. So we'll get into more detail, but the thing you need to remember when it's talking about all of the roots, all of the zeros and roots mean the same thing. The complex zeros, you just look at the highest degree, and that's how many complex. When you're looking at imaginary roots, you take the highest even exponent. So 2 is the closest even exponent to 3 without going over. And then remember, you subtract by 2. So there'll either be 2 imaginary roots or 0 imaginary roots. That's it.